All right, we are looking at quadratic functions or quadratic relations. So far, primarily all we've ever graphed is a line. So now we're going to start graphing what we call a parabola. Now, the degree of a quadratic function is 2. All right? The standard form of a quadratic equation is as follows. Y equals ax squared plus bx plus c, where a can't equal 0. The graph of any quadratic function is a parabola whose properties are as follows. The parabola is a single vertical line of value. Okay, let me go through all of what we need to know today. So a good portion of what we're doing today is going to be information that you're going to need for your cheat sheet. These are things that you want to know. Now, I'm going to start with the very basic parabolic graph. Y equals x squared. And I'm going to start the graph by creating a table. And I'm going to put in values on this table, and you're going to get to see kind of the idea behind what a parabola looks like. So I'm going to start with the following values. I'm going to have x equal minus 2, minus 1, 0, 1, and 2. Now I stick them into my equation. What is minus 2 squared?
4.
4 minus 1 squared?
1.
0 squared?
0.
1 and 4. So my parabola looks like this. 1 and 1, negative 1 and 1, negative 2 and 4, 2 and 4. Okay? All right. So, a few things that you want to know about the parabola. The first thing is, it's symmetrical. Okay? So it's symmetrical, which means that there's something that's dividing this into two perfectly symmetrical halves. The left side and the right side go up at the exact same rate. This line right here, we refer to it as the axis of symmetry. Now the axis of symmetry is the line that's drawn straight through what we call the vertex, that's this guy right here, that divides the graph into two equal parts. So it's exactly the same on the left side as it is on the right side. The equation of that line will be x is equal to whatever value the x value of the vertex is. So we're going to get to all of this in a second. I'm just going to use what I want you to see from this graph. This line right here, or this dot right here, that is called the vertex. The vertex has about 2 or 3 properties to it that help us describe this parabola right here. Okay? So in this case, my vertex is 0 and 0. The x value of the vertex is used for the equation of the axis of symmetry. So x is equal to 0 because that line is a vertical line going through x equaling 0. The y value of the vertex tells us a couple things. First of all, if the graph opens up, then the y value of the vertex is a minimum value. All right? All of my y values are greater than that right now. So therefore, this value right here, 0, is a minimum value. So if I asked you what the range was for this graph, I'd have y is greater than or equal to 0. Okay? So the y value of the vertex tells us what my range is. If it opens down, then it would be y is less than or equal to that value, whatever it is. Okay? So the parabola has a single line of symmetry. The highest or lowest point is the maximum or minimum. And I'll talk about A in a second. the y-intercept as well, bless you, the y-intercept of the parabola is also my c. In this case, my c is 0. All right. Now, what we need to be able to do is we need to work with 3 separate equations. All right. First of all, the standard form. And we need to be able to tell all of these characteristics of the parabola based on the equation itself. All right. Now, you can always draw it out. You can put it on Desmos, whatever. But you need to be able to tell the characteristics of the graph. So, right now, the first thing we want to do is look at the a value. That's the coefficient that's in front of the x squared. So there's a couple things that it tells us. First of all, if a is greater than 0, the graph opens up. If a is less than 0, this graph is a reflection over the x-axis. Therefore, it opens down. So there's the first thing that it tells us. Does the graph open up or does the graph open down? The second thing that it tells us is how wide or narrow the graph opens. So for example, okay, so I've got y is equal to x squared. So there's my graph of y equals x squared. Okay? So now, I'm going to adjust my a value. That's the value that's in front of the x squared. Okay? So the first thing I'm going to do then is I'm going to make it a 4. So now the equation is y equals 4x squared. So do you think that the graph is going to go open wider or narrower because of that 4 being in front of the x squared? Narrow. Some say wide, some say narrow. Well, I want to show you what happens here. My first equation I said was this, y equals x squared, right? And I had x, y, I had minus 2, minus 1, 0, 1, and 2. And that was 4, 1, 0, 1, and 4, right? Agreed? Now if I look at 4x squared, and I use the same x coordinates, what happens to my y? It what, sorry?
Increases.
It increases by a factor of what? 4. Because what am I essentially doing? I'm taking whatever x squared was and then doing what to it? Multiplying it by 4. So this would be 16, 4, 0, 4, 16. Right? So it's actually going to open up quite a bit faster then, which therefore gives us a much narrower graph. So by your a value being a larger value, the graph is actually narrow. Okay, it goes up a lot faster because you're multiplying all of your y values in your original by 4. So if I change that to 1/2, let's say, so 0.5, what's going to happen to it then? It's going to go up wider, right? There it is on the outside there. Okay, so it goes up wider because I would multiply all these values by 1/2. So it's going to go 2, 1/2, 0, 1/2, 2. So far, so good. So by adjusting the a value, I can determine how wide or narrow the graph is. I can also determine on whether or not the graph opens up or down. So I'm going to delete all graphs, graph the original, x squared, and now I'm going to add a negative to it. So what's going to happen to the graph now? It's going to open down. There it is. Okay. So now that I know that, my vertex is still 0 and 0 in this case, right? Still right there. My vertex again is the highest point to the lowest point. It's also the coordinate that is on the tip of the turn, whichever way you want to look at it. It's pretty straightforward. Okay? Now, is that y value a maximum or minimum now? It's a maximum because all the other y values are now smaller than that. Agree? They're all below it. So when the question says, okay, what is the maximum or minimum, or is it a maximum or minimum? If it opens down, it's always a maximum. If it opens up, it's always a minimum. Okay? And what determines that in the equation? A. Whatever's in front of that x squared determines that. Okay? How are you doing so far? All right. Now, we don't talk about this a lot because there isn't really a great influence on it, but I will talk about it because the book is. It says a quadratic function is defined by the following equation. So it's got y equals minus x squared plus bx plus 3. Okay. So there's my equation right there. It says make a prediction about the effect of the corresponding parabola when the value of b is varied. Test your prediction by trying several values. Okay, first of all, does this graph open up or down?
Down.
Down. How come? Because the coefficient in front of the x squared is a negative. So it definitely opens down. What is the y-intercept in this equation? Y-intercept is 3. Who doesn't know how come? We all understand why the y-intercept is 3? Yes? Anybody not? All right? Remember, the y-intercept is when x is 0. So if I put 0 in here and 0 in here and I add those zeros together, what do I get? 0. 0 add 3 is 3. So when x is 0, y is equal to 3. That's my y-intercept. All right. So I'm going to fiddle around with b. Now, like I just finished saying, it's not that important for me to worry about the b value, but we're going to do it anyways because the book asks us to look at it. So let's just have a look then at this. What happened here? Come on.
How do you punch that into your Desmos?
Okay. What's that?
How do you put it into Desmos? What do you put for B?
Well, that's what we're going to talk about. We're going to change b right now. Okay? So I have negative x squared plus something x plus 3, right?
Yeah.
So I'm going to let the first thing that we do, b is going to be 1. Okay? So we'll just put it in as 1 and let's see what happens. All right. So first things first, the vertex is right here. Okay? Y-intercept is right there. You know what we call these two guys right here? Well, what's happening to my graph at that point on the line right here? Intercepts. They are. They're my x-intercepts. Those are my x-intercepts, okay? They occur right here and right here. Now, here's something that you don't know. There are 3 terms we're going to use for x-intercepts. We're going to call them x-intercepts, we're going to call them roots, and we're going to call them zeros.
Zero. I've heard that one before.
Now, the reason we call them zeros is because what is the y value when it crosses the x-axis? It's 0. So we call them zeros then, right there and there. Okay, so my b value here is 1. So let's change my b value to 4, let's say. Any ideas what's going to happen to it?
Well, I'm going to open up.
Okay, so what determines whether it opens up or down, Rob? The negative. Right, so that's not changing.
Your vertex.
The vertex might change, possibly. Possibly. Right now my vertex is, oh, there it is there. It gives it to us. My vertex is 0.5 and 3.25. There's my vertex right now. So let's hit 4 and see what happens. There. Now what is my vertex?
2 and 7.
Well, you shift it the other way too.
It's like 2 and 7.
It's about 2 and 7. There's my vertex. So my vertex changed. What else changed?
And move to the right. The whole
Yeah, it shifted to the right, didn't it?
Your
Yes.
maximum.
So it shifted to the right. My intercepts also changed. They also shifted a little bit left to right. In this case, all right. Okay? So far, so good? All right, let's make that a negative now. See what happens.
Negative
just be on the other side. But
Make it negative 4. What do you think's going to happen?
it'll just the same thing on the other side of the Y.
Okay. Well done. Well done. So what's changing then?
Just the
We're moving the graph.
X intercept.
So you added negative 4x?
We're moving the graph left to right. Basically, that's what that's doing. It's moving it left to right. It has moved it up as well. Okay, so there was some of that because it moved from here to there or here to there. But the main thing is you can clearly see that it moved the same amount both times, whether I added a 4 or subtracted the 4 as my b value. Okay? This is just minor. We're tinkering right now. That's all we need to do.
line.
Just tinkering with the equation. It's going to make a lot more sense as I get into 7.2. Okay, go ahead, Bach.
The 2 big ones go up and around, and then they
Yeah.
cross at 3.
They still go, your y-intercept never changed because my y-intercepts remained at 3 here, right? So the only thing I changed was my b value in that equation, and that moved it, it shifted it left and right and up. Now, have a look at these. It may not appear it to you, but they are still the exact same width, right?
Oh yeah.
All driven.
Right, because what value affects the width only? The a value. So they are the same width. So all that changed by changing my b value is I shifted it left and right and up and down. Okay? So far? All right. Let's flip over now to page 182. Actually, let me use what we just did to talk about it. Okay? So a parabola that is a graph of a quadratic function is symmetric about a vertical line, the axis of symmetry through the vertex. If the function y equals ax squared plus bx plus c has an axis of symmetry that is defined by the equation x equals d, let's not get into all that. Let me explain what's happening here. All right, first of all, we have to know a lot more because we're still graphing domain and range. What's the domain for a parabola? How far left does this graph go?
Infinity. Down. It does go left infinity.
Left what?
Negative infinity.
Negative infinity to
Positive infinity.
positive infinity. So what's another way to describe something that goes from negative infinity to positive infinity?
All numbers.
All real numbers. Okay? Your domain will not change for this graph ever. Your domain will remain the same for every quadratic equation. It will be x is an element of all reals. The range is solely dependent on where the vertex is. So we said that this vertex right here was 2 and 7, right? So what can we learn from it? First of all, is it a maximum or a minimum? It's a maximum value, right? What is the equation of the line of symmetry? So I'm looking for this equation of this line right here. That line divides this blue graph into 2 equal parts. So when I ask you the equation of the axis of symmetry, you are going to say x equals 2. In this case, whatever the x value of the vertex is, 2. That is the equation of a line. That's the equation of a vertical line. That's the equation of the axis of symmetry. So we need to know the equation of the axis of symmetry. All right? What is my domain for this graph? X and element of all reals. Good. And what is the range for this graph?
Like 7 to negative infinity, or negative
Wow.
infinity to 7, whatever.
Okay, so we always go, all right, good. I like the way you said that, actually. What's the lowest it goes?
Negative infinity.
Negative infinity. So if I was telling you to write out your range, I would go negative infinity
And then 7.
to 7. And is this a round bracket?
No.
What is it?
The box bracket.
It's a square bracket, box bracket, that's right. Why? Because it includes it. Because it includes it. It's equal to that. You can't equal negative infinity, but you can equal 7. Right? So the other way to write your range, I talked about this last week, y such that y is less than or equal to 7. And then I should write in here all the time, y is an element of all reals.
That's a lot more
So-
reading.
Okay? And the domain, like Brock said, was x an element of all reals. Like that. Or negative infinity to positive infinity. Okay? That's basically it. So the characteristics that we need to know, we need to know what a vertex is, we need to know what the axis of symmetry is. We need to know what part of the equation affects whether it opens up or down, whether it opens wider or narrower. All right? We need to know max and min. We need to know the range, as well as the domain. These are quadratic functions. We need to hammer this out. You'll do it again in pre-calculus. Those that are in pre-calculus, we spent a lot of time on this. We spent a lot of time on this year too because we do it again in grade 12. We do a lot of work in which I will always go back to what we do here to show you how to do much more difficult graphs, because this is our starting point for doing polynomial functions. All right? It really isn't very complicated. You have your Desmos, so you can look at these graphs. You need to know what I've shown you on the board, the vertex, the axis of symmetry, domain, range, max, min. You need to know all of those things. You need to be able to decipher those things from an equation. You need to be able to get those things from a graph. We eventually spend a lot of time on these guys right here. Our roots, our x-intercepts, our zeros. We spend a lot of time on those. Okay? That's it today.
And you only have roots when you're going down.
No. Oh, that's actually a good point, Amber. No, you have roots anytime it touches or crosses the x-axis. Now, it is possible for you. Let me show you 3 possibilities for the x-intercepts or the roots. Since I have it up on here. There are 3 possibilities that you can have. We are going to spend, like I said, we're going to spend a lot of time on this. You can have 2 roots. Which crosses the x-axis in 2 spots. You can have 1 root, in which your vertex, 0, your vertex is on the x-axis, and you could have no roots. If it opened up and it was shifted above the x-axis or below the x-axis, okay, you would have no roots there. It wouldn't touch the x-axis. So there are 3 possibilities for roots. Okay? Five questions on 181. And then there's about 13 questions on 7.2. So that's what you're working on for the rest of the period today. Okay?
Volleyball people are gone tomorrow.
Oh, that is going to be a rough one. All right,
Holy.
let's go through 7-3 then.
Oh,
Good man.
It's a good thing you told me that,
yeah.
because you're gonna miss it otherwise. Okay, let's go through 7-3. It's not much more. I just explained it. In fact, take a look at the page. What did I just explain to you? Roots. Roots.
So you need to do it then?
So I'll just see what. Let's look at the example question.
No, Rowan, you're good.
Okay, so you need your Desmos. So if you have your Desmos, it says solve this quadratic equation by graphing. All right. Now, the one thing that I will point out for this. So basically, we're looking for the roots. We're gonna, and those of you that are in physics, I did this with you yesterday on factoring. All right. This is exactly what you're doing today, except instead of factoring, we're going to use our graph. So you could actually use this method in physics to solve that question in which the balloon's going up.
Like one of the four methods you already gave us.
And they
No,
drop
no.
the ball.
We drop the ball,
Oh, a different one.
right? That balloon goes up and you drop it, and then you have the negative 4.9 starting point. You could use this method and graph it and find your zeros. So it would take you far less time to do. Okay?
I should tell us this one in physics too.
So punch this into your calculator right now, into your Desmos. Minus 4.9 x squared plus 19.2 x minus 5.2. And just let it equal to y as opposed to 0.
Minus 4.9.
We don't have a
Minus 4.9.
maximum.
It's on page 186. No, not yet. Okay, so what you should have in Desmos is this. Minus 4.9 x squared.
But you have to put
Plus
equals 0?
5.2 subtract.
Why?
Subtract.
How do you
Okay, so are we listening?
Throw on one there.
Put it as y equals. Put that into your equation or into your calculator.
You did squared.
How do you square it?
Oh, yeah, you
Any
don't have
square
decimals, but you
squares
have
are all
decimals, yeah.
big number
Okay, use your
Oh.
decimals. Somebody ask me a question here?
I just said how do you
Just
square
like
things?
this
We just
skinny
use
long
the.
graph.
8 squared, isn't it? Yeah.
Yeah.
Okay, so you've got that in there, right?
Yeah.
All right, now, it says to solve this quadratic equation. When we're solving this quadratic equation, everybody put your calculators down for a second, just watch. When we're solving for it, what it's asking you to do is find the roots, the zeros, the x-intercepts. So that means that occurs when y is 0, right? So what I want you to do then is I want you to pinpoint on there. Okay, let's do this. Let's find all the information that we need out of this. So the first thing you do for every quadratic equation is find your vertex. So let's find the vertex in this equation. What is it?
1.959,
959 and
13, and 608.
608. Okay, so there's my vertex. All right. That's my vertex. What is the axis of symmetry?
2.
What is the axis of symmetry?
1.959.
That's not what I'm asking you for.
X equals.
X equals.
1.
I want x equals 1.959. If I ask you what the axis of symmetry is, you're telling me what the equation of the line is that divides it into two equal parts. Yeah.
I got 0.14.
The vertex?
I don't know.
Check your equation, make sure it's right.
I have 1.959. Well, I'm right.
Yeah.
Thanks for sharing,
What is
Ron.
your equation?
Okay, sorry. Okay, That's my axis of symmetry. Is it a maximum or minimum value? It's a maximum value because it opens down, correct? So far, so good. All right. What else do I need? I got maximum, minimum. What are my roots?
1.690.
1.690 and 0 and
30 out.
And negative 1.6.
That's not what we have.
I mean, Rob said he got them all.
Yeah, my bad, I did that.
all right.
0.
I need you to stay on task here, please.
0.293
0.293
and 0.
and
3.626.
So it's like that's your, you're like already squaring.
Is that what you guys got?
Yeah.
Go back down.
okay. There's my roots. There's the answer to the question.
Here's a small x.
It asks you to solve the quadratic equation. That's the answer. You're just finding your roots in this equation. All right. Our goal will be to do this without doing calculator work, but for 7.3 we do it just using the calculator. Paige, go ahead.
How did you find the axis of symmetry?
The axis of symmetry is always x equals whatever the x value of your vertex is.
Yeah, that makes sense.
Okay? Because your graph splits in half at that vertex all the time.
Oh, yeah.
Awesome.
So then, for in physics, that would be like one of those would be like your time.
Yeah.
Okay.
Yes.
And the other one would be what?
One was positive, one was negative, right?
Yeah.
So you cancel out the
Oh.
negative one because it can't have negative time. Okay, so the final thing I need you to do is my domain. What's my domain on that graph?
Domain is all real numbers.
X the number of all reals. You gotta get used to writing it. Okay, and what is my range for this graph?
Negative infinity. 13.608.
Very good, bro. There you go.
And we don't really worry about y's domain range.
Sorry?
We don't worry about the domain range for y.
Can't even do it.
Domain is the x values of your graph, and the
Yeah.
range is your y values of your graph.
Oh yeah.
Oh yeah.
Okay? So far, so good? Yes? No?
Yeah.
All right. We're gonna take it one step further. Okay? Any questions? Any other questions about it? So this is all the stuff. So basically what I'm telling you is on your cheat sheet, you need to write that out. I need to know my vertex, my axis symmetry, maximum, minimum, roots, domain, range, and then I would draw like three graphs to show the difference. Okay?
On cheat sheet.
We could open up, down, maybe one root, 0 root, 2 roots, whatever. You can do whatever you like. I'm just saying. Okay.
How are you supposed to draw 3 graphs out of that?
Like,
No.
Give me for example.
I'm saying put 3 examples on your cheat sheet. All right, look at example 2. Okay. Before you put anything into your calculator, I want to talk about this. So that's a quadratic equation, agreed? All right, we're not going to put anything to our equation just yet. Now, there's 2 ways in which we can solve this. The first way in which I want to solve this question, all right, would be to graph this side and graph this side and find out where the intersection points are. That's one way to solve this question. So we're going to look at that, we'll do that, and we're going to make sure it matches up. The second way to do it is to get it all equal to 0 and then find your roots from one graph. So I want to start with that. So I've got 2x squared minus 5x add 3 is equal to 6x minus 3x squared, right? So I'm going to get this equation equal to 0. So that gives me 5x squared minus 11x plus 3 equals 0. So now that I have it equal to 0, I can graph this on my graph. Instead of 0, I'm always going to use y. Okay? So let's go y equals 5x squared minus 11x add 3. And let's find out what the roots are for this equation. So graph it on your calculator now. And give me the roots.
Do you want me to say them?
Yeah, for sure.
Oh, 0.3190, like dash 0.
Yeah.
And then 1.8810.
Perfect. So there's my answer to the question. I solved it. Now, here's the thing. I want you to pay attention here. What does that tell us? That tells us that if I put this in for x into this equation, or this equation for that matter, if I put it in for x, the left side is going to equal the right side. So if I go 5 times 0.319 squared, subtract 11 times 0.319, and add 3, I'm going to get it equal to 0. If I put 2 times 0.319 squared, subtract 5 times 0.319, and add it to 3, that's going to be equal to 3 times 0.319 times 2 subtract 0.319. These roots right here tell us that the left side is equal to the right side. That's what they do. That's why I solved this question. I'm looking for values of x. Now, how does this relate to what we've done before with a line? Well, if I took the equation of a line, 5x plus 3y is equal to 15, and I took a coordinate that was on here. Hold on a second, I'm going to do this. Just give me a minute. Let's do, 0 in, no, I'll do that anyways. Okay, so I'm going to take this coordinate here to be 0 and 5. All right? So that coordinate's on this line here. So we've graphed the lines, right? So if I put 0 in and 5 in, the left hand should equal the right hand side. So 5 times 0 plus 3 times 5. What's 5 times 0?
0.
And 3 times 5? 15. So as long as the x and the y value are on the line, when I substitute them in, the left-hand side is going to equal the right-hand side. We've done that. That's what equation of a line is. States that every coordinate on that line creates an equation in which the left-hand side is going to equal the right-hand side. So now when I go back here, oops, went too far, I have this value and this value because there's 2 coordinates. All right, now what I want you to do is I want you to graph this equation right here. And I want you to type it into your calculator as equation number 1 is 2x squared minus 5x add 3. Equation number 2 is this side. So graph those two. Graph those 2 equations.
You want to like put them on separate lines?
Yes, yes. Separate and then find out where they intersect at. So graph your y1 is 2x squared minus 5x add 3. Your y2 is 3x times 2 minus x. And find out where they intersect at.
And make it equal to 0?
No. No.
You know why?
Y1 is this. Y2 is this. And tell me where they intersect.
0.319, 1.609,
0.319.
and then 1.609.
609.
Still 609, yeah.
Okay? And then where's the other intersection point?
1.881, 0.671.
So if you look at the two x values then, what do you notice about them?
Zero roots.
They're the same as the roots when I got the whole thing equal to 0. Your answer for your question is that right there. So you can do it both ways and still get the right
I
answer.
like the other way, run this way.
Okay? All right? Questions or concerns about that?
Should be good.
Okay. We won't go any further than 7.3 for the next 2 days. Okay? So you work through that.
And you drop a line.
Yeah.
And it goes up. So like this one, and the line's parallel. It just went up and down and I couldn't find it.
That means that you have, that means you graphed it without the y. You need the y in there.
Yep.